Hello friends, welcome to Matrices online class. In today's topic, we are going to look at the concept of matrices. After definition of matrices, we looked at the types of matrices. After looking at the types of matrices, we now looked at application. Where do we apply matrices? I hope you are following. Thanks. Let's go. Okay. Look at the topic matrices. And a matrix is a rectangular array of numbers or variables. The numbers of rows and the numbers of what? The numbers of columns is called order of matrices. Order of what? A matrix. Order of what? A matrix is called order of a what? A matrix. If a matrix has m rows and n columns, then the order of the matrix is written as m by n matrices. It is always used, or it usually was denoted by what? Bold capital letter. What is a matrices? A matrices is defined as arrangement of numbers or array of numbers in rows and what? Column. So you must arrange it in rows and what? Column. Example, matrices is just denoted by what? A, I, J, where I is the road side and J is what? The column side. So that is all about matrices. So when you arrange numbers in what? Row 1, row 2, row 3, column 1, column 2, column 3. Example, arrangement of what? A hall, examination hall. If you want to write your WAEC or GC or any exam, they will arrange you in a matrices form. Even when you want to be in what? Assembly ground, you are going to be arranged in what? In a matrices form. So arrangement of what? Numbers in rows and column is called matrices. Okay, now let's go. We are going to look at what we call, and the matrices is always what? Denoted by what? Capital letter. If you want to say matrices A, you are going to write it as what? Matrices A. Not like this. Okay. So we are going to look at what? The types of matrices. We have what we call a row what? Matrix. A row matrices is a type of matrix that contain exactly one row, or a matrices that contain only one row. Example, if you have a matrix A is equal to A11, comma A12, comma A13. This is what's called row matrices. Or if you have something like B equals to 1, 4, 6. This is what we call what? A row matrices. So a row matrices is a matrices that of the form this. Or a row matrices is a matrix that has exactly one row. That is it. Okay. Thank you. That is what we call a row matrices. 2. Let's look at 2. Column matrices. A column matrices is a type of matrices that has exactly one column. Example, when we have A equals to A11, A12 in this form, this is what we call a column matrix. Or B equals to A11, A12, A13. Any matrices in this form. Or we can say D is equals to 10, 11, 20. This is what we call what? A column matrices. Any matrices that is of this form is called what? A column matrices. Okay. Okay. Now 2, 3. Let's look at what we call a null. A null or zero matrices. What is a zero matrices? A zero matrices or a null matrices is a type of matrices that contain or contain what? Zero. It's a type of matrices that contain what? All zeros. It means that all the entries of the matrices are zeros. Example, I have it A equals to 0, 0, 0, 0. This is what? A row, a zero matrices or non-matrices. We have another one B equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is a type of matrices in which all the entries or all the elements are what? Zero. We call it what? A zero or non-matrices. Thank you. Okay. That is it. I hope you are following. 3. Let's look at 3. Identity matrices. Identity or unit matrices. This identity matrices is a type of matrices in which their leading diagonals are 1. Unit matrices or identity matrices is a type of matrices in which their leading diagonals are 1 and others entries are 0. And that is it. So, okay, example, when we have A equals to 1, 0, 0, 1. B equals to 1, 0, 0, 0, 1, 0, 0, 0, 1. Any matrices in which their leading diagonals are equal to what? Unit or 1 is called what? Identity matrices. Their leading diagonal always what? 1, 1, 1 throughout. A type of matrices in which their leading diagonal contain 1 throughout is called what? Identity matrices. Okay. Thank you. I hope you understand it. Okay. Now let's look at another one called diagonal matrices. Diagonal matrix. Diagonal what? Matrix. Diagonal matrix is a type of matrix in which their leading diagonals are what? Numbers. But if it is identity matrices, their leading diagonals is what? A unit 1. Diagonal matrices is a type of matrix in which their leading diagonals are numbers and other entries are zeros. Example, A equals to 2, 0, 0, 5. B equals to 4, 0, 0, 0, 6, 0, 0, 0, 10. So this is what diagonal matrices. A diagonal matrices is a type of matrix in which their leading diagonals are what? Numbers. But if it is identity, their leading diagonals will be what? 1 throughout, while others are 0. So that is what definition of diagonal matrix. Okay. Now let's look at final one called what? Square matrices. Square matrix. Square matrix. What is a square matrix? A square matrix is a type of matrix in which the number of the rows are equal to the number of the column. A square matrix is a type of matrix in which the number of the rows are equal to the number of the column. In other words, the I is equal to J. In other words, the M is equal to N. So the number of the rows are equal to the number of the what? Column. And that is what we call a square matrices. Example, A equals to 2, 5, 1, 6. And we have another one. B equals to 1, 6, 1, 1, 5, 2, 2, 3, 8. This is what we call what a square matrices. It's a situation whereby the number of the row is this 1, 2, and column is what 1, 2. We call them what 2 by 2. In other words, I by j. So the number of the row 1, 2, that is 2. 1, 2, that is 3. You must first of all count I before the j. That is, you must first of all count the row before the what the column, and that is how to do. So this is what I by what j, which is what 2 by 2 matrices. Now look at this one 1, 2, 3. We call it 3 by what 1, 2, 3 by 3. So a situation whereby I is equal to j is called square matrices. A type of matrix in which the number of the row is equal to the number of the column is called what square matrix. We still have non-square matrices. Non-square matrix is a type of matrix in which the number of the rows are not equal to the number of the what column. In other words, I is not equal to j. Okay, so we call it what square or non-square matrix. So we call it what square matrix. Non-square matrix is a type of matrix in which the number of the rows are not equal to the number of the column. Example, let's just have A equals 2, 1, 2, 2, 3, 5, 6. Let's read 1, 2, 3. This is 3 by 1, 2, 2. In other words, I is not equal to what? J. So the type of matrices in which the number of the rows are not equal to the number of the column are called what? Non-square matrix. Okay, thank you. Finally, we are going to look at what we call singular matrices. Singular matrices. Singular matrices. This singular matrix is a type of matrix in which the number of the what? In which the determinant. This is a type of matrix in which what? The determinant of what? A matrix is equal to 0. So whenever you find the determinant of a matrix and the determinant is equal to 0, we call it what? A singular matrix. Example, determinant of A is equal to 0. If after solving determinant of A and you get is equal to 0, we call it what? A singular matrix. So a singular matrix is defined as a type of matrix in which what? The number of what? The number of in which what? The determinant of a matrix is equal to what? A 0. Is defined as what? Is defined as what? Whenever you solve the what determinant of a matrix and it gives you equal to 0, we call it what? A singular matrix. So now we still have another one called non-singular what matrix. Non-singular matrix. Non-singular matrix is a type of matrix in which the determinant of a matrix is not equal to 0. So when you solve any determinant and the determinant is not equal to 0, if the determinant of a number is not equal to 0, we call it what? Non-singular what? Matrices. And that is how to solve it. So if a determinant of any given matrices is not equal to 0, you call it what? Non-singular what? Matrices. In other words, if you find like a determinant of a matrix, say let you have just 2, 3, 4, 5, and after finding the determinant, you get something like that. Determinant is equal to 5. If the determinant is equal to number, we call it what? A non-singular matrix. But if after solving determinant of any matrix and you get at the end that your determinant is equal to 0, you call it what? A singular matrix. That is how to do it. Okay, you should go on and verify and search for more types of matrices and know their meaning and application, how and the examples. But at least these 7 or 8 of them is okay for you. Now let's look at what application of what matrices. Matrix. Where and where do we apply matrix? Okay, one, matrices are used to solve what problems in electronics, optics, quantum mechanics, statistics, robotics, linear programming, optimization, genetics, etc. That is where we apply matrices. We use it to solve problems in electronics, optics, mechanics, statistics, robotics, linear programming, optimization, genetics. That is where we apply them. Two, matrix calculus is a mathematical tool used in what? Connecting a linear equations, linear transformation, system of what? Differential equation. Matrix calculus is a mathematical tool used in a connection with a linear equation, linear transformation, system of what? Differential equations. 3. Electricals and mechanical engineers, chemists, biologists, scientists all need what? Knowledge of matrix to solve a problem or complex problems. Chemicals, electrical and what? Mechanical engineers, chemists, biologists, scientists all need the knowledge of matrix to solve what? A complex problems. Okay. 4. In a computer graphics, matrices are used to what? To project a three-dimensional image on. To project what? A three-dimensional image on to a two-dimensional screen and create what? A realistic motion. In a computer graphics, matrices are used to project what? A three-dimensional what? Image on to a two-dimensional screen and create what? A realistic what? Motion, etc. Finally, but not the least, matrices and determinants are used to what? To solve a system of what? Simultaneous linear equations. That is where we are going to solve many of them. Either we use a Cramer's rule method, or we use inverse method of solving the system of our linear equation, or we use what we call echelon form of matrices, or we use what we call the Gaussian elimination method of solving it. And that is how to solve it. And that is where we are applying what? Where we apply matrices in life. So God bless you. Now that is the summary of what we call matrices and where we apply them. The types of matrices I've explained it. If you have any question, go to the comment section and ask me. I'll come there and answer your questions. Thanks and God bless you. We have studied the meaning of matrices, the type of matrices, and the application of what? Matrices. When we are discussing the meaning, after then we discuss the types and the examples of them. Now we went further to discuss about the applications of matrices in everyday life. Thanks and God bless you. Remember to subscribe to my YouTube channel, Matrices Online Class. Bye.